All right, time to compute surface area, and so this first one, it's our sphere equation again. Yay, sphere. And so you're probably rolling your eyes at this and saying, Professor Wright, we need to do all this calculus just to show that the area is 4, or the surface area is 4 pi. And I'm like, yeah, yep, we're going to do a lot of math just to show that the surface area is already what we know. Okay, well, let's get underway. Alright, so we need to find the length of the normal vector and integrate that across our domain D. Okay, well, let's do it. Well, to do that I need t theta. Okay, and if I find t theta, okay, so derivative with respect to theta of our parameterization, and I just get minus sine phi, oops, let's try that again, minus sine phi cosine theta, or sorry, sine theta, sine theta, and then sine phi cosine theta, comma 0, oops, not theta, comma 0, okay, and then t of phi, okay, is cosine phi cosine theta, comma cosine phi sine theta, and then minus sine phi. Okay, and now I need to cross these, right? So, and order does matter, and the order was tangent, or t of the first parameter crossed with t of the second parameter, which were theta and phi respectively. Okay, and now this is something that I did off on a separate piece of paper because I didn't want to waste your time doing the cross product. So minus sine squared phi cosine theta, it's kind of long, and then minus sine squared phi sine theta. Okay, and now after simplifying, this last part becomes minus cosine phi sine phi. Okay, there ends up being a cosine squared sine squared, which you can factor out, and then you can go on with your life. Okay, so I did a fair amount of work to get this, and just know that it could take you a few minutes to actually do this out by hand. Okay, and then so when you look at the length of this, again, something that I did by hand off of the screen here, I got just sine of phi. Okay, a lot of work to get there. And so then next I need to integrate over domain D of this. So this, and then this is going to be d theta d phi. D theta d phi, bad phi, there we go, better. And so then this is going to be from 0 to pi and 0 to 2, or 0 to 2 pi of sine of phi, and then d theta d phi, which this part I'll do out because we can actually do this quickly. 2 pi and then times integral of times negative cosine of phi, and then from 0 to pi, which ends up being 4 pi. Woohoo! So, one example showing what we already know, but just using the surface area. So, for surface area, again, you need to find the normal vector, but not necessarily at a point, because we're not given a point. So find the general normal vector, find its length, integrate over domain D. So, we'll do one more example, and then we'll be done with videos.